Hey guys, today I want to talk to you about something that was very hard for me to understand, the implication in mat210, the symbol of implication. What does it mean? It took me a long time to understand the concept in computers, in software engineering or TE, whatever it is. So the basic concept is A um, primer, the minister is elected. B, well, because the prime minister promised that he's going to lower the taxes, so the taxes are going to be there's going to be more money. Okay, so the concept is like this: A, the guy was elected. This implies B, there's going to be more money. So this is very hard to understand because if the guy is not elected and there is no money, well, this concept is true, which means that we are only interested in the fact that the guy was elected. Once A is true, then B is being considered. Otherwise, B is not considered if A is false, which makes no sense. I mean, if you think about it, why would the guy would be if he's not elected? How would you know if in the case you would be elected, you would lower the taxes? We don't know. So it looks like something funny. It's like we give him the benefit of the doubt that if he was never elected, then in the case he would be elected, he would lower the taxes. So we believe that he was if he's not elected, this concept is true. It means that would he be elected? He's not lying, basically. If he is not elected, he's not lying. But if he's elected, then let's see if he lies or not. It makes no sense. I mean, because most politics they're not that true to their words. So if he was not elected, I mean, it makes no sense. It'll make more sense to say that the thing is false because we know that. Why wouldn't people elect him in the first place? Because they know he's not going to do what he's saying, whatever it is. So I found the concept in software engineering because it's very hard to see why they teaching us this kind of stuff and what is it useful and what do we need this implication, and it just makes no sense. And when you ask the teacher, he'll tell you, oh, but it's just practical. It's very practical to see it this way. Just make a lot of practical things. But what practicals, we have no idea. So I would like to show you what I found a place in computer science, in software, that this is practical. Let me stop the video 2 seconds. I'll come back to you right away to see to see how I'm going to explain this to you. Okay, so before we go into the concept of the implication, let's see what is the domain about. I'm talking about the use of the implication in software engineering. I found it in graphic OpenGL programming and graphic game engine programming, or whatever it is, like in graphic log 750, graphique informatique, machin truc. So the way they explain there is that, let's say you want to draw a scene where you have different elements in the scene. It's actually a graph. You'll have like the main element and you have a sub element. The main element of a scene is the scene itself, I guess. The node, the first node. And then you have subnodes, like when you open Unity, Unity, Unreal, whatever it is, any game engine, you'll see like hierarchy. Like I have the main node, and then you have subnodes and subnodes. You have lights, and you have like sprite, and you have like different like elements, colligible, and whatever it is. Like it's a graph. It's a tree actually. So let's say I have this scene where I have like what is this? Eight circles with a square and some text. And I want the user to be able to select one of the circles only. I don't want them to be able to select the square. I don't want them to be able to select the nothing else, just the circles. So the way they suggest to do it there is that anytime the mouse moves, you redraw the whole scene, check where the mouse is, and redraw the way the scene is right now. So you would know any second where the mouse is. But the scene could be very complicated. So in order to be able to know where you are, when you redraw the scene, don't draw the square because it's not selectable, and don't draw the text. You redraw the scene with the circles, but each circle has a different color, and the background should be like whatever is not selectable should be a constant color. Here it's transparent, I guess, but in the software it could be colorful. So you see, when the mouse goes here, let's say, everything is repainted in a split of a second, and we see this is the color where the mouse is. We know that this color represents that element in the scene, so then we know that the user is here. So redraw the thing, and in my lab I had to show like a feedback, so the thing had been redrawn in a different color. Let me show it to you in the software directly. Let me stop let me stop this a second. Let me show you directly in the software how it works. So here you have like a skybox where like 6 walls of the world. See the water and the sky and everything. Here you have a tool. This is a player that you could move around by playing with the arrows. I think it's working. Yeah. Okay. And then this here is 100 square by 100. Let me turn this into sphere. It's gonna be easy to see. Change all. Change. Doesn't work. Okay. Whatever it is. This is 100 square by this is 10 by 10, 10 cubes by 10 cubes. They're glued to each other, so we don't see the difference. But whenever I move the mouse, everything is redrawn, except that this time we don't draw the tool and we don't draw the sky box. We don't draw the light, obviously, because the light would change the color of the cube, the face of the cube. Actually, here it's by face. You know, I'm selecting a face. So everything is redrawn. We take the color of the mouse, where the mouse is. We redraw everything, and then we draw a small square to tell the user where it's been selected. If you look at this side of the screen, where's the cursor? If you look at this side of the screen, whenever I'm not in selectable item, the color, the pixel data color is black, and the coordination is this. So when I go here, see it's black. But when I go here, it's a different color, like 119, whatever it is. So that's basically it. Now, to draw this, see, we can even add, oh, I put it sphere, there you go. Now it's easier to see, very good. So when I click on Shift click, it adds the element. So this is for the demo. Now I hope you understand what I meant here, like how it works. And this is really a scene graph. You really have to see this, like all the elements that you see here are in a certain graph, a tree, where you have the tool, you have the skybox, you have the player, and every circle is a node in the graph. And we associate each node with an ID and with a color whenever we redraw, whenever the mouse moves. And if you look at this here, well, nothing happens if I don't move the mouse. But the moment I move the mouse, everything is redrawn, and we try to figure out where the cursor is and what the color is under the cursor, and that's how we know the face of the element. Okay, whatever. I hope you understand. It's not that complicated. Yeah. Let me now show you the code and where the actual instance of application has been found. So let me stop the recording 2 seconds. I'll be back in 2 seconds. Okay, so this is the code. Now, this is draw from here. So you take a node. The code is in C++, by the way. Log sets and count is C++. So you have like a node, and in the node you have draw from here. So it's a recursive call. You know, it calls itself like draw from here, like next one as next. You know. So we look at the tree and we go down and we try to see like each element down to draw the next element. You know, we'll look at this, which let's say this is the treatment of the current element, and then we go to the next one. Well, actually, we take the children and we go to, for each child of this node, we're going to go recursively call this. When we call this the first time, there is a variable that is sent, and this variable is selectable only. So this time we want to draw the elements only selectable, or we're going to draw the scene without selectable items. So if we want to draw only selectable items, then this implies that we have to check if the element is selectable. But if we don't want to draw selectable items, we don't care if the thing is selectable or not. We're going to draw it anyways. So this is where I found an application, and it was weird for me to realize that it works in this case. And I'm sure there's many cases, but I just want to help you out because it took me a long time, and I saw other people asking these questions and all that. And here you are. I mean, if this element if we're trying to draw only selectable, then for sure we want to know it's selectable, not selectable, you know. But if we want to draw everything, we don't care. If we don't want to draw only selectable items, then we don't care if the item is selectable or not. We have to. So then I put it this way, but according to the teacher, there's no character to be used in order to do this in software, in programming, especially C++. So I look at the blue sheet that they give us and found the equivalence, and the equivalence is this. So then I put it here, and magically it works. You know, I did some tests and everything is working. So there you go. I hope this answered your questions. If you liked it, just press on the like button. If you have some comments, don't hesitate to comment. And you know, I hope this helps. Thank you for watching.